Hello, let us integrate 1 divided by x times the ln of x. This is a fairly famous integral to do. The graph for the function 1 divided by x times ln x is here. X times ln x becomes 0 at x equals 0 or x equals 1, and it is negative in the interval from 0 to 1. So if you do 1 divided by x times ln x, you will approach minus infinity as x approaches 1 or x approaches 0. And then x times ln x becomes infinity as x approaches infinity. So 1 divided by it becomes 0 as x approaches infinity. So that's how the function looks like. How does one integrate it? Well, this is a very, very easy function to integrate it. Although I believe that when I saw this for the first time, I had to think about a minute before I saw it. But yeah, really, I mean, this is really just 1 divided by x times 1 divided by ln x, right? Like so, 1 divided by x times ln x, that's just 1 over ln x times 1 over x. And what is that? I mean, you're basically having 1 divided by a function times the derivative of this function, right? That's exactly the joke. I mean, 1 divided by x is just the derivative of ln of x, right? So you have 1 divided by a function times the derivative of a function. And the integral of that is, of course, just the ln of the function. And as I've said, the function is ln x, so yeah, the integral of this thing is just the ln of the ln of x. There you go, you're done. I assume that some other teachers would want you to make a substitution here, so you can, so it all works out fine, like something like maybe, I don't know, u equals ln of x, so that 1 over x would become the du, because that's the derivative of the ln of x or something. But yeah, let's be honest, you don't need a substitution. You can just see that. And because this always works, right? I mean, if you have, basically if you have f prime divided by f, then the integral of that is just ln f, right? So yes, in total we get that the integral of 1 over x times ln x is just the ln of x. And we kinda use this rule, if you want to say it like that, the rule, so to speak, that for any function f from r to r, the integral of f prime divided by f is just the same thing as ln of f of x, right? Again, I don't really want to say rule, because that's kinda exaggerating. I mean, you don't have to make this a rule. I mean, this is just really obvious, right? That's why I'm almost afraid of saying a rule, you know, the rule of integrating f prime of divided by x by f of x. I remember that back in school, we did actually have this as a rule to memorize, you know. Oh, you have to memorize the rule that the integral of f prime divided by f is just ln of f. But yeah, come on, I mean, that's just obvious. That's not a rule that you have to memorize. And so let us just verify our solution. That's the graph for ln of x. And if we take the derivative of it, let us add the derivative and draw it in purple, then you can see that this is just 1 over x times ln of x. It seems like ln of ln x is only defined if x is greater than 1, which makes sense, I think. Let's think about this quickly. The ln is defined only if x is positive, right? But the thing is, if you plug in a number in ln of x that is smaller than 1, then you're negative, right? Because the ln of 1 is equal to 0, right here. And if you're below 1, then your natural log is negative. And you can't plug something negative in the log. So that's why ln of x is only defined for x is greater than 1. Let's just randomly draw the normal ln of x so you can see how I meant it. There we go. Ln of 1 is equal to 0, and then if you're below 1, then the ln is negative and approaching minus infinity. So that's why you can't plug in negative values that are smaller than 1 in ln of ln x, you know, this green thing. And that's it for this video. See you guys in the next one. Okay, so as I just recorded this video, I realized that it does kinda suck that 1 divided by x times ln of x is defined for every x greater than 0, but our integral that we got, the ln of x, is only defined for x is greater than 1. I mean, that did kinda suck, didn't it? I mean, we want to integrate this little part here too. And in order to fix this, we need to make sure that in the first ln, all positive values can be plugged, and you can make that sure by putting ln of absolute value of ln x. Right, so this green thing here is ln of x, and now let us look at the ln of the absolute value of ln x. And then we get this thing here. It's here the same thing as ln of x, but then we also get values for x is less than 0. And if you take the derivative of this in proper, then we do get 1 divided by x times ln of x, and now we get this little parabola thingy here too. So that's nice. Yeah, I haven't really put an absolute value in an ln x integral in ages, right? I mean, you do technically learn that the integral of 1 over x is ln of absolute value of x, but I always leave the absolute value when I do integrals in my head. And yeah, but by drawing the functions here, I noticed that something was missing, and that's why we put the ln of the absolute value of ln x here instead, so that we can really integrate the entire function 1 divided by x times ln x, and not just the part for x greater than 1. So actually it was kind of useful that I'm always drawing the functions in my videos. It's not just visually nice, but at this time it was also useful, because I would have done this wrong otherwise. So there you go. That's really cool, I think. It's the ln of the absolute value of ln of x. There we go, guys. See you in the next video.